Newcoat originated from concept back in 2014, mainly to produce niche products, to fill a gap in the market for self-adhesives that the bigger players in the market don't produce and wouldn't entertain producing because of volume. There was a distinct plan to produce using UV technology. As you can imagine, we discussed what we required with UV adhesives, how do we cure them. So then we talked to coating line manufacturers and TS Convert and Elite Cameron.
We design machines specifically to suit customers' requirements. The project that we engaged with our friends here at Newcoat was to develop a range of UV-based hot melt applications where we brought together lots of different disciplines all in one machine to enable them to produce products that traditionally would have been made using solvent-based and water-based systems.
Through a lot of development, we started the first production runs in September 2018, and year on year we've grown ever since. The typical production and products in the market are solvent-based or water-based adhesive technologies. What we wanted to do from day one is become a greener production site for those product ranges. So we produce rolls of 50 to 100 meters. They tend to be digitally printed and they accompany with a corresponding laminate film to protect the printed image. Then we take a step up to a longer lasting range of materials with a polymeric base, which is probably 5-7 years lifespan. Then you look at some more specialities, so more aggressive adhesive types. Then metallics for decorative applications, so point of sale, vehicle signage. As our recent experience of the pandemic, flow markings, flow graphics. So quite a broad spectrum of applications. Flexibility is key for us. We can change very, very quickly, whereas in comparison to some of the main players, that could take days and weeks in the campaign type production that they operate under. We also don't need the large volumes that they require. With a small footprint of our coating line, that's probably half the length of a curing oven for our competitors. We achieve a cure within a few meters only. Whereas if I compare that to a solvent-based system, you're looking at a minimum of 50 meters to set up their process, and probably until they validate what they've actually coated and cured, you're into hundreds of meters of material before they start. We probably can verify within 10 meters of a setup. You don't have to worry about destroying any solvent waste, either through extraction processes or recycling, cleaning. So we are completely solvent-free. We're able to recycle all of the cardboard waste, and anything that's non-recyclable is sent to create energy from waste. We have no requirement for additional heat sources, abatement systems, all using electrical energy. You don't have the concerns about the destruction of the VOCs that are generated, which is through another heat source of either an oxidation chamber or some sort of abatement system, which also then emits a certain amount of pollutants into the air. The heat that's generated through the UV lamps, we have filtered through carbon filtration to destroy ozone. And then we generate the warm air that's recirculated back into our warehouse. So we reuse that heat energy out of the process. And again, that reduces what we emit to atmosphere.
I think there's a big emphasis on that on every machine at the moment, that we have to design with the environmental issues in the forefront of our mind. And coating is a massive opportunity to have a big effect because, of course, it's using a lot of product on a continuous basis. UV hot melts enabled us to get away from the traditional methods of coating, and the customers see the benefit.
So if we look at some of the large department stores in the UK, they tend to want very green credentials. So we have a range of non-PVC products, and the UV technology becomes attractive to them because of that factor. So they have an understanding of what our reason for being is, and that starts a dialogue. Most of the competitors, they can't profess to be green. It is an interest gainer, shall we say, for want of a better description.
The design of the lamps and the cassette system that we use for the hot melt coaters is excellent. The guys at GW are able to produce something quite special for us. We have on this particular machine 4 bays, 3 of which are being used and occupied by lamps. The 4th is an opportunity to increase the performance for higher running speeds as and when they become a requirement of the customer. The UV monitoring system for the lamp condition was a great benefit because ultimately the performance of the end product is determined by the amount of treatment that you apply to the adhesive. We have the whole hood on a retracting system for cleaning. So the whole hood pivots up and we can remove each of the cassettes by sliding them, loosening off the bolts, sliding them out of the machine so you can do any maintenance and cleaning functions out of the cassette itself. Very, very fast, very easy to do a clean up and get back in operation.
The advantage of the UV adhesives versus the conventional is the ability to vary coat weight, and the durability it's quite aggressive in some applications. The UV has a lot of benefits in stability.
Traditional hot melts, which are rubber-based adhesives, are not particularly good in performance in extreme conditions. There's been a lot of development with the UV range of hot melts, which can not only match but also outperform in many cases the traditional products. You extrude 100% solid adhesive onto the product, so there's no carrier as there would be in a solvent and a water-based system, which you then have to remove from the process, and that's where a lot of energy goes. It's a very cost-effective way of producing high-performance laminates.
The remote monitoring of the system has been also a help. The ability for someone remotely to look at the system and confirm and advise them what's going on. Albeit minor problems, the things that we've in the main contributed ourselves, particularly in the early phases when we've had to use it once or twice, and each time the support has been precise, prompt, and it's fixed the problems. Looking at the UV system from the concept of the pilot line trials into the scale up into full production, it's followed a stable path, and everything we want from it has been provided. So it's very easy to work with. It's very easy for the operators to understand and maintain, and support that we get and guidance, particularly in the early days. We wouldn't be where we are today without that.